We're going to take a look at number 48 from chapter 11. It's very similar to number 47. Still talking about rowers, expert versus novice, so we have two samples. Instead of looking at angular knee velocity like they do in 47, we are now looking at weight and kilograms. And we have this pink block, which was produced by SAS, or SAS, which is a statistical software package or program. And it's really done the work for us. So if we know what we're looking at here, we can just answer this very quickly. Let me translate that. This is sample size. We have a 10 and an 8. If we're doing conservative, we would have done 7 degrees of freedom. But you'll notice down here that they've used that fancy formula to calculate 11.8 degrees of freedom. So we'll just let the computer do that kind of thing. We're not going to do that by hand. And they've provided this for us, but as I mentioned in a different video, we're not going to look at pooled variances where we assume the two samples have the same. So we can just ignore that line. And really we have our research up top with our two samples and the information, the data that's been gathered. And then we have our calculations down here, our results. What did they calculate for us? They calculated a t-value, which we usually think, or at least we show in our book. Most places they have it as a lowercase t. I don't know why they changed that to a capital. Degrees of freedom, and then this is our p-value. Notice, and it mentions this both in 47 and 48, that SAS gives you this absolute value. In other words, the area to the left of the negative plus the area to the right of the positive. So that would be the two-tailed or doubled p-value. And we'll take a look at that in the long version. But real quickly here, we just take a look. Yes, there's a difference in these two means. We have sample 1 and sample 2 means. I see there's something like 2 kilograms, 1.9 kilogram difference. The whole question here is about that difference. Is that 0 or is it not? And they've given us the two S values, and then this is kind of nice. If you were calculating t by hand, they've gone ahead and done S divided by square root of sample size for a standard error. But really, it's all about this. P-value is enormous, right? We're comparing that to either 1%, 5%, or 10%, typically 5%. P is definitely larger than 5%, whether you divide that in half or not. In the long version, we'll talk about why we're not dividing that in half. And since 62% is definitely bigger than 5%, we fail to reject the null hypothesis. We put that into English, which is that, here's a good sentence for you. I won't write it down, but I'll say it. Although the mean weight of the skilled group was about 1.9 kilograms heavier, the difference is not statistically significant. And so there is not enough evidence to support the claim that the being skilled makes a difference in the weight of a rower. Let's take a look at the long version. So let's go back to the beginning and look for a claim. And it's actually phrased as a question. Researchers are wondering, or it doesn't even say research, it just says, is there a difference? Is there a difference? So if we put that into a statement form, the claim would be, there is a difference. There is no preconceived notion of whether the expert rowers are heavier or lighter, so there's no reason to lean left or right. It's not a one-tailed test. So how do we write that? I'll put it in this form first. The mean weight of the skilled rowers is the same as the mean weight of the novice rowers. That is the null that says there's no news to report here, there's nothing exciting. The claim, if you're saying that there's a difference, we're saying that there's not. Just a coincidence. And then over here is the alternative. And in this case, as I said, there's no reason to suspect higher or lower. We don't look at the research. The current research is not setting up all our alternative hypothesis. It would come from prior knowledge or prior suspicions or theories. So that's one way to set up the hypotheses. And then if you just do a little subtraction and subtract the mean of the novices from both sides. I don't really have room to write it here, so I'll just say it. We're going to subtract the mu sub NOV from both sides. What would you get? Well, you would get this as the subtraction. We'll just call that the mean difference. And then you'd have 0 on this side. And this just has an advantage of not having to use real numbers. As you discuss this, we don't have to compare 70.5 to 69.6. We can just compare the difference to 0. Is it 0 or is it significantly different than 0? But those are mathematically the same thing. And then that sets us up for our test. Let's name our tails. 47 does have a theory or a claim, a preconceived notion that the angular knee velocity is higher. So that is a right-tailed test, and you have to divide that p-value in half because they tell you the software has given you the two-tailed or doubled p-value. Here, though, not equals means that if we were going to go through the whole process, and we can just in our minds, we don't have to do this math, but I'd like you to have this in the back of your mind. What is that significance level mean? If we talk about 0.05 significance, we're talking about this total area, half of it over here, half it over here, and these are our rejection zones. If our research value lands this extreme, left or right, we're going to reject that null hypothesis. The null hypothesis is that it's 0 or somewhere close to 0. And here we've defined this white area as somewhere close to 0 or not significantly different than 0. The blue areas here are our, nope, there's the null hypothesis is incorrect and it is not 0. There is a difference. Okay, and then you do your research. And the research, we're not going to calculate that t-value by hand, though I'm sure we could. And you did in number 41. And they gave us something like 0.514. So what does this mean? Well, we did not land in the rejection zone, did we? As a matter of fact, the p-value is so large that it takes up a lot of that white space. And don't forget, we didn't have a claim that talked about greater than, so this is also p-value. If we were looking this up in the book, we would just get the right-tailed answer, and it would be about 30%. We don't get real precise values from the table, but whatever we get, it is a right-tailed value, and we would have to double it. What did that... see if we can take a look at this. Remember, it was about 62%. Where did that 62%, what is that referring to? Well, that's referring to 31% on this side of 0 and 31% on this side of 0. And this red zone is the probability that we would get from our samples that value or further away from 0. This is where we're speaking in terms of absolute, because absolute value. 0.51 or further to the right from 0, or negative 0.51 and further to the left from 0. But that's a lot of, if I just shade in this red area here, this is a lot of just, oh, it's random, it's not real. This is not significantly different from 0. We had to be out in the blue tails to be significantly different. And these sample results are showing you we've got a large possibility of just being a little bit to the left, little bit to the right of 0. In other words, not significantly different. Not significant. Now, where did that come numerically? Not significantly different. based on this idea that P is much greater than alpha. I mean, it doesn't even come close to 10%, 5%, or 1%.